Hi there. This is Intro to Malloc, Exercise 2, and it's all about the ordering of Malloc and free. We have a binary, and all it does is it has a list of pointers. And when you malloc, it adds it to the front of the list, and when you free, it removes it from the end of the list. And then there's also a function to show all the pointers. The goal is to get the chunk that was originally made at index 1 into slot 10. It's kind of like heap feng shui in a way. Now, for the hint, it's that the chunks are going into the unsorted bin. This is because we're using a version of libc that does not have tcache yet in order to make this a little more viable for the fast first in, first out way that the unsorted bin works. Now, if we go to the terminal, we can see how this program works. This program is called Birdie, and we have a couple different options. We have option 1, which is going to be create malloc. We have option 2, which is going to be free. And then we have option 3, which is just going to show the pointers. If we go to create malloc right here, we can see that we're first creating a chunk of size text 110. And then, it's going to be weird, but we're putting a chunk in the middle. And the reason we do this is we don't want any consolidation or anything to happen. So we don't have a pointer to this, so we're not going to free it, but I didn't want consolidation to cause issues here. Then we have a global, so pointer is the name of the thing we just allocated, but at the very top we have a item called pointer list, and the pointer list is going to store all the pointers. Now if we go to free, it's literally just going to call free on the pointer provided. Now if we go down to the bottom, and the actual calls here, we see with create malloc, it's storing the pointer in the last index, and then it's going to increase what that is. After that, we have the beginning index, and it's going to keep track of that. So the beginning index keeps track of the beginning of the list, and the last index keeps track of the end of the list. And so we don't do anything really funky and cause other memory corruption issues. So let's look like in practice. We can't just run the binary straight. You could, but it won't have the same functionality because you use a different version of libc. So like usual, we can do start.py. Now we do start.py, there's nothing happening in here. So if we do control B arrow, we can see what's going on. And if we do 3, we can see all the pointers. We can see our target is getting this slot in index 1 into index 10. Now, we can call free, and this will remove the pointer from index 0. So now the A000 ending 1 is gone. We don't have access to that. And if we go back down here, and we call bins, which is a command to show us the various chunks in the bins, we can see that we can see this chunk in the unsorted bin. So this is freeing it. Now if we go back up and we do malloc, it will actually allocate that same chunk into index 0, or index 6 there. So the index 0 chunk got allocated into slot 6. Now, I think the easiest way to solve this is probably just like do it in the terminal, but if you really wanted to, you can actually go in here. Oh, whoops. Gosh dang it. Exercise 2, tmux. So now we can actually look at it. And there's a couple of different functions. The first one is malloc, second one is free, and that's all you really need to solve this. So you could just call malloc and free from the start.py like this, but I actually find it easier to just do the interactive version of this. It's one of the few ones where you actually can just do it interactive. So to recap, we have 5 chunks being allocated at the very beginning, right up here. It's going to call, sorry, we have 6 chunks being allocated at the very beginning. We is why we have index 0 through 5. And we need to get the chunk that is at index 1 to begin with to index 10 in this list. And if we can do that, then we've done the heap function correctly and we'll get the flag. So have a good time and good luck.